Okay, so the way we're going to work it is I'm going to cover what is digital transformation and some of the components on a general sense, just so you have a good foundation of what we're talking about here today. And then I'm going to hand things over to Rajiv, and we're going to really talk about how digital transformation is being used in revenue cycle management and what some of the cool projects are and results that are being achieved there. Digital transformation is probably one of the most overused words these days. In fact, it's getting up there with cloud and big data in terms of what the heck are people talking about. There's a lot of hype. And what is big data and small data? I've never seen what small data is. So we're going to begin our journey here by taking a closer look at digital transformation. And it's really about creating new ways to do business by exploiting digital technologies. And it's driven by data insight. And by that, I mean the ideas and roadmap for what to transform comes from data itself. So there's really an explosion of data everywhere you look. So think about it. Just about every action someone takes is now captured in data. So finding meaningful patterns can result in new process design. And that could lead to new and better ways for businesses to literally amaze their customers. So understanding data is really the key to unlocking things like self-service, dramatically shortening intervals for provisioning things, providing more visibility, and making better suggestions to customers on what they can purchase next. So let's take a look at a couple data insight examples to really drive that home. So I'm sure you're all familiar with Uber. It's one of the great examples of digital transformation. So the Uber app has revolutionized local travel, making it just so easy to get from A to B. And you may not know, but over 14 million trips are completed each and every day. So think about 6 years ago, there was no Uber. So in doing this, they're compiling petabytes of data on consumer habits. And this allows them to deliver outstanding service. However, there is a downside to having so much information. If you give a data scientist a ton of data, you might not like what they come up with. So for example, Uber a few years ago caught a lot of grief for touting their ability to predict one-night stands. So you might be wondering, how the heck did they do this? Well, they drilled into data to find anyone who took a ride between 10 p.m. and 4 a.m. and then took a second ride within 1/10 of a mile from the previous night's drop-off point 4 to 6 hours later. All I got to say is yikes. That's a big overreach. But they, of course, stopped talking about this. But it remains a really good illustration of the secrets buried deep inside data. A more useful example and pragmatic example of data insights is predicting an epileptic attack. It's now possible to predict an attack 20 minutes before it happens. And the way they do this is with a wearable device that collects EEG data. So the data is analyzed by predictive models that recognize patterns of EEG activity that are in a specific window in advance of a seizure. And my last example of digital transformation is Airbnb. So I'm sure you're all familiar with this model by now, and you've probably all, or many of you stayed in an Airbnb a room. What you might not know is that in just over 10 years of being in business, Airbnb has more rooms listed than Marriott, Hilton, and IHG combined. So it took around 100 years for those properties to build their capacity. So Airbnb isn't just new technology, it's a new model, and it's really the essence of digital transformation. So companies in every industry are using data and analytics as competitive weapons and innovation catalysts. So according to Gartner, a company's ability to compete in the emerging digital economy, it really requires faster-paced, forward-looking decisions. So you may have seen this infographic before. Most companies are still in the bottom left. That is, they're primarily using descriptive analytics to explain what happened. The magic comes when data is used to tell us what will happen, and then really how can we make it happen. So that's where everyone's heading. So now we've defined digital transformation, let's take a closer look at some of the technology components before I turn it over to Rajiv. So digital transformation is a symphony of different components. And like the instruments in a symphony, each component plays an important role. Now, not every transformation requires each component that you're seeing here. Some processes can be digitized with only a few components, such as RPA, machine learning, and intelligent workflow. However, companies that lead in digital transformation have strong competencies across all of these components. In the interest of time, I'm only going to focus on a handful of these that are being used extensively in the revenue cycle management automation efforts. So artificial intelligence is another one of those overhyped technology terms. It's common to lump all automation efforts as AI, and that's really incorrect. As we'll learn in a moment, robotic process automation is not AI. So what is AI? It's the theory and development of computer systems able to perform tasks that normally require human intelligence, such as visual perception, speech recognition, decision-making, and translation between languages. Another way to think of it is, whereas AI is the brains, think of RPA as the brawn. So AI is the simulation of human intelligence by machine. RPA, on the other hand, is a software robot that mimics human actions. So in simple terms, AI is concerned with thinking, and our robotic process automation is associated with doing. So whether you like RPA or not, one thing is certain, this technology is literally exploding. And according to Gartner, 40% of large enterprises will have some form of RPA in place by 2020. And that's up from about 10% today. And based on the poll results, it looks like everyone is some form of that journey. So that bears out with what we've seen here today. So to better understand RPA, let's unpack the definition and look real briefly at some of the key components. So first, configurable software. This is out-of-the-box software that comes with built-in functionality and doesn't involve writing lines of raw code. So think of RPA like Microsoft Excel. You don't write a spreadsheet application every time you need it. You just build macros and models and use the features that are inherent in Excel, and that comes with the program itself. So that's kind of how RPA is from that standpoint. Second, business rules. This allows, this is really the decision criteria or constraints that determines how a process is to be executed. These are the bread and butter of getting complex processes done correctly. For instance, in accounts payable, if the product you ordered is received, then the firm pays for it. That's an example of the simplest possible business rule. Sequence of actions, that's third. This consists of a series of steps taken to complete actions across multiple systems. RPA can handle sequences of actions ranging from simple tasks such as creating and updating reports to more complex tasks such as managing work absences or balancing taxes on erroneous invoices. This concept is fundamental to identifying the right processes to automate. Automatic, fourth, means that the completion of tasks is done independently, and once the rules are programmed, the processes are just carried out. Fifth, the definition references operating across different software systems. So I'm willing to bet that everyone on this call is running on dozens of different systems, using different systems, from homemade systems at your hospitals to Oracle to SAP, and that's really not going to change anytime soon. So teams interact with and integrate across these systems to get work done. So the key is that RPA mostly operates on the front end of all these applications. And that's similar to how people use them. So you don't have to get rid of applications. RPA just allows work to get done on these applications much faster. Now, finally, exception management. As capable as RPA is, there will be times when a person needs to step in. So and that's what exception management is. So that's when employees are tasked with resolving unforeseen events, or contributing their judgment or discretion. Sometimes this is a full intervention in which a person takes over the entire transaction, and that's referred to as an assisted bot. And sometimes it's just a small request for input, after which the automation continues on its merry way. So this type of automation is done with what's called an assisted bot. So let's take a quick look at the many benefits of RPA. Perhaps the most obvious benefit that's self-evident is cost reduction. So to put it simply, bots can slash labor costs by reducing the number of people needed for repetitive tasks. So here's some example. Deutsche Bank plans to cut 15,000 jobs through automation. And Wells Fargo Bank plans to reduce annual expenses by close to $2 billion, in large part due to automation. So now there's really a far richer list of benefit types that you need to consider with RPA. And one of the most straightforward benefits is an increase in speed. So with RPA, process turnaround times are often significantly reduced because tasks can be completed much more efficiently when they're digitized. So you might be wondering just how much faster. Well, I've seen processes that once took 2 weeks to be completed in 2 hours or less, thanks to RPA. The next benefit is better compliance. So since RPA acts according to program rules and conditions, it can faithfully complete tasks that meet regulatory standards and protocols. Plus, I've seen audit times shrink drastically because organizations can quickly and easily prove compliance. On the customer side, RPA can help improve quality of service. There's certainly no harm in reducing the number of service errors thanks to automation. And unless, of course, you're a customer who enjoys battling companies over incorrect billing statements. So RPA doesn't get tired, doesn't have a bad day, or get distracted by flickering lights in the cubicle next to them. And that results in better quality. Another key benefit is operational agility. So if an organization needs to adapt to new process rules, the reduced overhead of automated processes makes it much easier to adjust and scale compared to traditional hiring and retraining. And for industries that have high cyclicality, think open enrollment for healthcare, the ability to rapidly scale a digital labor force rather than hire temporary workers can save literally millions. And finally, one area I find truly exciting is the impact RPA can have on the experience of a wide cast of characters. Whether you're a customer, an employee, or a patient, it's clear that service is better, faster, and more accurate for cause, and it's really a cause for celebration. So I've seen this materialize in the form of lower customer churn and lower employee attrition. So let's take a closer look now. The next thing I'm going to talk about is machine learning. So let's take a quick look at this video clip.
It's ready.
Please, God.
What would you say if I told you there is an app on the market?
We're past that part. Just demo it.
Okay. Let's start with a hot dog.
What's that? Jinyang, I'm going to buy you the palapa of your life. We will have 12 posts, braided palm leaves. You'll never feel exposed again.
I'm going to be rich. Do pizza.
Let's do pizza.
Yeah.
Okay. Here's that.
Not hot dogs?
Huh?
That's it? It only does hot dogs?
No, and a not hot dog.
That's a humorous but a real look of what machine learning really is. So in more specific terms, machine learning is the science of getting a computer to act without programming. So deep learning, a subset of this, can be thought of as the automation of predictive analytics. So one of the coolest examples of machine learning these days is Spotify. So I'm a huge fan and love the new music recommendations you get each week. So they know my musical taste better than anyone. So I'm amazed at how it finds songs that I would probably never find or know about. So Spotify uses 3 methods to predict. So first they use something called collaborative filtering. and that analyzes my behavior and behaviors of people like me. So stuff like what I have liked, what I've added to my playlist, how many times I've played it. So that rule is pretty basic. Next, it uses natural language processing models to analyze text. So that's kind of cool. They crawl the web looking for blog posts and other written text about music to figure out what other people are saying about specific artists and songs. So that's definitely getting a little cooler. However, I think the most amazing method of prediction is through audio models. So this involves analyzing the raw audio tracks using something called convolution neural networks. That's a big mouthful. So that's basically the same technology used in facial recognition software. So in Spotify's case, they've been modified for use on audio data instead of pixels. So the neural network spits out an understanding of the song from characteristics like estimated time signature, key, mode, tempo, and loudness. So how cool is that? Now, I personally have a very eclectic taste when it comes to music. I like the alternative genre, but I'm very picky about the type of songs I like. So my daughters razz me about it all the time and say all my music sounds the same, but hey, that's okay with me. That's how I like it. The final technology I want to touch on before I hand it over to Rajiv is intelligent process automation. So this is the combination of RPA, which is robotic process automation, machine learning, natural language processing, and other AI technologies. So in simple terms, intelligent process automation is an advanced version of RPA when it comes to comprehension, intelligence, and precision. So it analyzes prior decisions and actions, learns over time, and then gets smarter and more intelligent to make decisions. So I've covered all the basics. I'm going to turn it over to Rajiv now, and he's going to talk about how digital transformation is working in revenue cycle management.
Okay, so as I said, we've all, Glenn referred to a number of examples as consumers. I'm going to focus a little bit more about the world that we all live in, which is the revenue cycle world. I wanted to cover some of the nuances that exist in the revenue cycle world. I'm sure most of you would recognize some of all of these. And these do have an impact when we think about machine learning or AI in the revenue cycle world. The key message here is that given the number of specialties, payer policies, exceptions, they all play into heterogeneity. And the reason why we would do a machine learning or an AI application is really to achieve some kind of return on investment and ROI. And the fact that there is so much heterogeneity in the revenue cycle as compared to maybe some of the other industries, banking or insurance, it really sometimes makes it difficult to prove that ROI. And that's something that we would like you to be aware of. As we all know that clinical documentation is key to the revenue cycle. And here, one of the facts that Glenn talked about, natural language processing, can play a really big role because it's possible to parse clinical notes and make some decisions based on that. We all know in revenue cycle, SME tribal knowledge is extremely important. And what AI is trying to do is mimic that tribal knowledge. So we need a way to be able to capture that tribal knowledge. Additionally, as we look at QA or audit, we all know that we're trying to achieve high reimbursement whilst being compliant. And there is obviously, so much workload available in terms of people, FTEs available to do the work. So audit is also a good candidate for a machine learning application. The basic concept here is that if you can rank all transactions by error propensity, then you could cover all 100% of the transactions and not waste effort on auditing good transactions. So in order to do the compliance tests, OIG has certain software called RADstats. It's possible to load and run those RADstats programs as well. So the concept here is if I can take all my transactions, rank them by error propensity, based on historical data that my machine learning model has produced, I can then focus on transactions which have a higher propensity of error and do an audit on them, and with a smaller workforce achieve a higher audit result. The challenge here is we all have biases. We have biases when we are doing the work humanly. Some of those biases get propagated via the data into a machine learning model. So we've got to be aware of potential for bias and test against that. So as I move on, these are some of the use cases. I'm sure you're familiar with all the bullet points on this slide. I'm not going to go through them. But I've indicated against some of these points how either robotic process automation or certain features of artificial intelligence can be used for these particular functions or use cases. These are some of the sample use cases we've implemented in our own processing centers. And these solutions may or may not be important for you. Every shop is slightly different, so every operating environment is slightly different. But we've seen significant benefits by implementing these particular use cases, and I'll share with you some of the benefits that we've seen in the next slide. So as I said, based on some of the use cases that we implemented, we've seen these kind of improvements. Productivity tends to be a common reason why people go towards these applications, which is we've seen a 30 to 40% improvement through assisted coding, billing, AR functions. Process time, that is the turnaround time. We all know there's after certain long weekends or there have been certain spike in loads. The RPA functions help in handling any load swings and completing the work faster. We've in fact, when we started doing some of the machine learning based coding, we were challenging our experienced coders against the machine learning models, and invariably the experienced coders would win. But over time, we've seen that equation equal out, where the machine models are getting as good and sometimes even better than experienced coders. There's a lot of emphasis that can be put on actionable intelligence. That is, you do executive dashboards. Everybody does BI reporting, I'm sure, where you're looking at BI reports through the rear view window. But you can actually set up certain actionable intelligence inputs, for example, equity shift analysis or physician productivity, which kind of help you look forward and do some root cause analysis by the machine. It's typically cognitively a person can look at 3 or 4 parameters in an Excel spreadsheet, but it's the long tail that wags the dog. So when you've got 15, 20 different parameters impacting a decision, it's hard to do that cognitively. But for a machine model, it's if you give it the compute capability, it's possible to achieve that. I think Glenn touched on these. I'm not going to go over them again. But the message here is that there are multiple components for any solution. Not all are required in every solution, but some are important in some cases and others are important in other cases. What we've seen in our experience is digital transformation is truly a team sport. And many times it's a contact team sport. So there would be difference in opinion between different teams. But it's important to really leverage different skills. And this is one good reason to partner with companies as well, because it's hard to get all these skills within one organization. And even if you have them in one organization, getting the priorities from all the team members may be difficult. This is a typical project life cycle that we've seen through our experience. There's a discovery phase. Everybody talks about data being the new oil, which is very true. But as we all know, the quality of data is extremely important. Taking the oil metaphor, just as we need to refine oil, there's a need to refine the data and make sure that, because otherwise it's always garbage in, garbage out. So there is a definite need to provide good quality historical data. I would like to share certain best practices that we've learned. Sometimes we've learned it the hard way. We started our journey about 3 years ago, and wanted to share some of the best practices that we've seen. Don't boil the ocean. This is, everybody sure agrees with this. Look for repetitive cases. Don't start with the complex cases. Start with decisions that can be fairly deterministic. Machine learning helps you take probabilistic decisions, but I would start with deterministic decisions that we can solve those problems, at least in the beginning. It's not an answer to a poor process. So if you automate a poor process, it might just go faster, but it still stays a poor process. Getting funding, getting stakeholders to agree is a challenge. So I would say it's important to engage all business leaders as well as stakeholders early in the process. Identify the reasons why you're doing it. You could be doing it for FTE savings, for improving quality, for improving compliance, for handling load swings. Not everybody does it for FTE savings. We've done it for reasons which have nothing to do with productivity. So it's important to identify those upfront, get all stakeholders to buy in. As we said, there are many digital options. Decide which ones you want to choose. And avoid getting into a pilot perfection trap. This whole process is very iterative in nature. It's important to recognize the iteration capability and iterate over a couple of cycles and not get too stuck in a pilot perfection trap. What we've done is run small experiments. Don't try and, I think robotic process automation, the word process is probably misquoted. It should really be robotic task automation. Look for point solutions, look for tasks within a process that you can automate, and just run those experiments, and it's okay to fail within that. We found certain people are innovative by nature and they want to try different things. Really find those innovators within the team and align their reward structures, and it can really make a big difference. As we said, data is the new oil. So sometimes we get so focused on data that we forget to ask the right questions. Why you're doing a particular exercise is extremely important. Don't get too absorbed in the technology and too absorbed in the data either. If you ask the right questions, we will not have the Uber-like examples that Glenn referred to. The idea typically here, what we've seen is we've not replaced any system. We've always tried to make the current system better and be open to insights from unrelated data. It's sometimes surprising what we get from data that we didn't, we thought as of no value. And really the user experience or design, because machine learning, a lot of it is under the hood. Like if you're driving a car, the engine specifications, not a lot of people know about the engine specifications. The engine specifications are very important to the engineers, but what the driver is looking for is something entirely different. So I think keep the focus on the design and visualization and user experience as well. Just to wrap up, I think it's important to address the elephants in the room. There is a natural fear of losing jobs or control. But in our experience, that has never been the case. It is not a race to the bottom. All it does is takes out busy work and helps allocate the teams to higher quality work and take out the mundane work. And we've never had to do any attrition because of any of these solutions. Trust of algorithms is important. Sometimes, especially the CNN networks that Glenn was talking about can be a black box, and the only answer to that is really to be able to test and validate it along the way. There are a number of ethical issues around machine learning and AI. What's the role of humans? What's the role of algorithms? I think it's important to address this. You can create bias. If the data is biased, the bias propagates very quickly in a machine learning environment. So we got to make sure we test and validate against that. There is a surprisingly, and there's an environmental concern, something that most people would not have thought about when it comes to AI. But there was a recent MIT Technology Review article which said training a large data set is equal to the carbon emission caused by 5 cars over their lifetime, because of the amount of power that is used to really train a large data set. So something to be aware of. Most technologies have pros and cons. So, but there is a huge capability of impacting human life in a positive way as well. We've seen a lot of examples in as varied as agriculture in poor areas to sex trafficking of minor children, a project that I'm closely involved in, and in the revenue cycle world as well. So I think there are pros and cons, and you've got to really decide for yourself, take help from outside consultants as well. At this point, we would be happy to answer any questions either now or later. So I'd hand over back to Maureen, and while Maureen is coordinating the questions, we'll just share with you a little bit about who we are and what we do. So that's the background on Apexon Health. Apexon, by the way, is a mountaineering term. Apexon means if you're mountaineering and as you're going up, the people coming down say apex on, which means keep climbing. So that's our motto. But we've been involved as an RCM or revenue cycle business for over 13 years and have a number of customers and a number of AI solutions, RPS solutions. And we'd be happy to share some more deeper experiences if anybody's interested. So back to you, Maureen.
Thank you, Rajiv. Okay, so we've got a question, and it is, what is the typical ROI if we use the robotic process automation in the coding process?
Okay, so I guess when you say typical ROI, what we've seen is it's very, it falls under your continuous improvement plan. So it's truly continuous improvement. So you may start with a 10% improvement. What we've seen is we've seen productivity gains of 20 to 30%, 3 to 4 months into the project, and 9 to 12 months in, we are seeing 40 to 60% productivity benefits. And then it's a matter of continuous improvement beyond that.
Okay. We've got another question, and it's, how long does it take to implement a simple bot?
So a simple bot is really a matter of days and weeks. You should not be looking. Simple bots can be built in a matter of days and weeks, probably tested in another week. So you're looking to put simple bots into use, into production in less than a month, typically.
Okay. And we've got one last question, and it is, do you recommend a particular RPA tool vendor?
So there are both open source and proprietary RPA tools. There are typically the three industry leading tools, which are UiPath, Automation Anywhere, Blue Prism, but there are dozens of tools. There's a healthcare oriented tool called Audit as well. We've used more than one tool, and I think in your strategy to be future proof, you want to be tool agnostic. But we've used a lot of UiPath personally. So.
Okay. We did get another question, and it is, what process would you start with?
I would start with a process that you see, that there's a high volume of work. Maybe it's not as critical in the project life cycle. and the rules are fairly clear. So it's deterministic, rules are clear, and you have good data. So if you can find a process that there's high volume so you can prove the ROI, you've got good historical data so the machine can learn from good historical data. And if the rules are simple, then it's easier to implement as well.
Okay. We have another question. I'd quantify ROI as cost to collect decrease and net collection percent if possible. Do you have longitudinal data of ROI for these conversions based on these metrics versus productivity increases, et cetera? Ideally, cost to collect on per claim basis or so.
Yes, I mean, there is data available.
Or some, yeah.
The reason it's kind of hard to give hard numbers is every shop is different. The operating environments are different. Your baselines are different. But at a minimum, you're looking at, 10% to 20% uplift in from wherever you are. So.
Okay.
So I don't know if I fully answered that question, but we'd be happy to take that offline because you've really got to baseline your existing costs and then move it up from there. So.
Okay. And that pretty much wraps up the questions at this time. If we do get additional questions after the fact, we will go ahead and make sure that they will get answered by the team. And so for right now, Glenn, Rajiv, is there anything else you'd like to say before I start to wrap up the webinar?
No, just thank you for the opportunity, Maureen, and we'd be happy to provide more details, as Rajiv said, both in terms of use cases and if you have ideas and want to bounce them off us on what can be automated and what can't. We do a lot of those types of discovery sessions with people. There's no obligation or pressure to buy anything. It's more of a talk to us about what you're trying to do, and we'd be happy to give some advice and of how to proceed. And really a big thing that we help people with is build an ROI, or at least a hypothesis on what an ROI can be. So if you're curious, give us a call, and we'd be happy to have a session with you and talk about that.
All right, so you can go ahead and put that information in on the question box. So I'd like to take this opportunity to thank Rajiv and Glenn from Apex on Health for taking time out of their schedules to talk to us about driving digital transformation in the revenue cycle.